let's conclude our discussion of Python, our whirlwind tour of the various features of the Python programming language, by discussing classes. Python is an object-oriented language. It's not as strictly object-oriented as, say, Java, but it still has the same features of a class system. You can create classes, you can use inheritance, and you can create a hierarchy of classes. We won't be doing much of that in this class, but it is a feature available to you. In this class, we'll be using a very limited subset of the object-oriented capabilities of Python. We'll mostly be creating very simple classes that resemble more C-style structures rather than a full-fledged class. So let's take a look at a very simple class that I've defined here. So this class is called foo, and we've created it by using the keyword class followed by the name of the class. Typically, the names of my classes have an uppercase letter to begin and are what's called camel case. Typically, I like to capitalize the words in my classes. Inside a class, you can create functions. Here we have 3 different functions inside the class. Not all of these functions have return values, and that's fine. If you do not explicitly give a return value to a class, it will return none. When you're defining a function inside of a class, the first argument is very special. It is called the self argument. If you've used Java, this is very similar to the this keyword in Java. And so when you actually call this, as we'll see in just a second, you don't use the self keyword. This is used implicitly by the programming language whenever you call an instance of the foo class. And so this allows the object that you've created as an instantiation of this class to remember, I am of class foo, and I can remember things over time when I'm called. So specifically what this class does is it allows you to save a value inside of it. So when you create the class, you can specify what that value is going to be. You can then change it with the set method by providing a new value that gets stored inside. And then you can also call the get function and return that value. Let's see an example of this. So if you create a class and store inside of it value 3, and then you call the get function, it returns 3. So notice that when we instantiate the class and when we call the class, there is no self. That is implicit. When you create the class, it is creating a new variable called self that remembers, I am this object of class foo. If you then use the set function to change the value stored inside this object, and then call the get function again, you get a different value because you have replaced the value inside with 4 when it was 3. Now, of course, to use the true power of classes, you want to have multiple instantiations of a class. And so we can create another instance of class foo and store in it value of 6. And so we can take f and g, 2 instances of class foo, call their get functions, and these have different selves. There are 2 implicit keywords called self, and that gets called. One has 4, one has 6, and when you add them together you get 10. So this is where this starts becoming powerful. You can have different instantiations of the same class, and each of those can have different data stored inside, but they have the same structure. Okay, so that wraps up our whirlwind introduction to Python. In class, we'll play around with some of these basic concepts and interacting with a basic data file, and also doing the first homework 0 that will get you acclimated to the homework environment we'll be using, and also get you used to the Kaggle competition system.